Let's take a look at the latest development of Nemilian, The Last Expedition. This update mainly focuses on the world of interactive environment and cool visual effects, which are mostly made using Niagara's visual effects system. So we'll look into how I made some of those in this video. When I dive into a new game feature, I always ensure it aligns with one of the game's main goals or mechanics. This update boosts our world interaction, which is a top priority. Let's talk about the rocket ship. It's tiny compared to the vast world it's in, and it's not overpowered, especially at the start of the story. In fact, it's quite vulnerable and can easily get destroyed because of natural elements. These dangers aren't targeting the player, but they can still be deadly, so they are a major part of the game. Therefore, I'm working on creating a diverse range of biomes. I've introduced a few new elements for player interaction, starting with the foliage that's all about visual interaction. It won't affect the rocket ship, but it might hint at hidden paths, conceal secrets, or simply enhance the area's appearance. I used Niagara for this, and it was pretty straightforward to set up. Alright, let's take a look at the animated flower blueprint. So this actor has two exposed variables for the colors. We've got two because there is a gradient here. Let's open it. So here it's very straightforward at the moment. It's probably going to be more later on, but we've got an arrow helper. This is used just for placement and orientation, and it's only visible in the editor. Then we've got a collision sphere. This is to detect the rocket ship position, and if we go inside it, then the animation that retracts the tentacles will start. And then finally we've got the Niagara's system. Alright, let's open it. Here we've got multiple emitters, but essentially they are the same. Only a few variables, like this one for example, is using a custom parameter, but on the others it would be the same parameter but multiplied by a different number. So we've got different variation of the same thing, but we don't need to create different parameters for each of them. So let's take a look at each node in order to create this. So here we've got the emitter state. The life cycle mode is set to self. That means that the parameters underneath will be set at the emitter level, as opposed to if you set it to system, all of them we use the system's settings. Here we've got an infinite loop, and the animation is gonna last. It's gonna be played every second, and you can also add a delay if you want to pause between each loop. And for the scalability mode, I'm using the system, so similarly to the lifecycle mode, you can use it to self or system. And here, if you set it to self, you can actually see the culling distance and visibility settings and the reset age on awaken. This is straightforward. If you cannot see the emitter on the screen, then it might be put to sleep. But then what happens when it's awakened again? Then should we reset the age? So you've got those settings right here. I'm gonna set it back to systems. Then we need a beam emitter setup node. So this is basically to trace like a line or spline between 2 points. And here we are spawning 100 particles all at once. So every second we get one set of those being spawned. Then right here we need to spawn beam node. This is so that all the particles are going to be spawned inside that line created in the beam. And actually the order of the particle is accessible into a variable we're going to see later. Initialize particle. This is a node just to set each particle settings, such as the color, lifetime, etc. Size. Then the beam width, I'm not using it at the moment, I'm not showing the beam, so it's currently set to 0. Then here we've got the scale sprite size, so this is so that you can scale each particle over time.
but you can also add more complexity to it. So here I'm using the normalized age, which means I get a value between 0 and 1. And this is the important one, the ribbon link order. So that's what I mentioned earlier. And this allows me to basically multiplying different variables and then divided by a certain number, I can get this effect where it looks like it's growing from the root. Then we've got the colors, so starting colors, end colors, these are the exposed variables we saw earlier. So in Niagara, these are user parameters, and you can just create your custom parameter and drag and drop your variable right here. And the lerp factor is again using the ribbon link order, and this is why we can have first color in the roots but second color at the end of each beam. Then curl noise is what's making the beam move on the sides. Drag, point attraction force, so currently it should be set to 0, but if I change this to 50, for example, the particles are attracted to the location of the point attraction force. So this is how I set my retracting animation up. Solve force and velocity, this is because we are using forces here, so we need that node. And finally, for the sprite renderer, the material of the sprite is basically the default material provided by the engine, but I modified it to make it less transparent, more opaque, and this is so that the color of the particle pops a lot more than if it was like the default material. Alright, let's take a look at the blueprint again. So here in the event graph, we basically have our begin overlap event from the collision sphere, and then based on it I can modify the custom user parameters created in the Niagara system so that I can play the retracting animation and change whatever I need to change the color, etc. So pretty straightforward. Here we also have a color change, and this one is based on a timeline. So creating a custom timeline is very straightforward. Just type timeline, add a timeline, and then you can set the overall timeline length and then add your keys right here. So over time, every time it updates the value, we update the lerp of the linear color, which is the color end here. So we are updating the color end based on that. And here I've got two different variables which are exposed, and these are the one we saw right here. And that's about it. So it's pretty straightforward. I'm probably going to spend more time on those flowers later on to improve how they look, but for now I think it's pretty good.
In this update, I also added Ivies. I tweaked an asset pack for this one to save some time, and because I made very similar elements in the past, I already know how to make them. I'm using a few assets for other 3D models as well, but I will replace most of them when I will be spending a few weeks purely focusing on 3D modeling later in the development of the game. The Ivies are mostly there for fun and looks, and there will be a lot more variation, so it's not too repetitive. These will also allow me to set up corridors with loads of them partially hiding the ship, and this is helpful as it will introduce flying with low visibility of the ship, and that's important because there are areas where you need to be able to fly short distances without being able to see the ship. Next, I worked on the animation for the teleportation feature, which I need because of the large scale of the world, and because I might add short sublevels that the player will teleport into. This animation is done using Niagara, so let's take a look at how I made it. Oh, by the way, please let me know if you would prefer to see more or less on how I'm making the game compared to just seeing the results. Alright, let's open this Niagara system. So first we need to spawn every particles all over the ship's 3D model. So that's pretty straightforward to do. Then we need to scale each particle over time so that they can appear and then disappear. So you can see on the graph, right before the explosion, the size is increased, and then after the explosion, it's slowly decreased, so they disappear. Then I added a jitter position node, which is creating this effect where the particles are shaking right before the explosion. Then for the actual explosion, you simply spawn a point force at the right time so that every particles are pushed in all directions. And finally, we've got the collision node, which allows for each particle to bounce around the world. So let's take a look at the final result with the sound. And by the way, for the sound, I simply took multiple samples, merged together, and I added a sound effect on top of it.
Next, I've got a spawner actor now, so I can spawn any type of actor everywhere I want, and I've got a bunch of settings for it. So let's take a look at this one here. So we've got specific exposed variables, activated on nodes, delay between spawns, max amount of actor to spawn, etc. These are the settings related to the actual actor that is spawned. Is it spawned with a initial velocity, etc. So this one, for example, result in this. I don't think we need to go in details on how this works, but it's basically spawning at a specific time a specific actor over time, and this allows me to get this type of parkour where you must avoid those projectile, but you could also, in a different scene here, you have another spawner right there. Actually, I can show you real quick. Player. So here it's set up so that when I press this button, we start spawning, and then I could have a small puzzle here where I must redirect those projectiles into this collector actor. And when I do that, it's gonna open a door, whatever. So it's pretty cool already, but I'm gonna use similar system for later on for lasers, etc. So that's a great update. Also, compared to the previous version, now the buttons have, like the cables for the button have an animation, so if I stop, it's not activated, but if it reaches the end of the cable, then it's activated. So that are making things a lot clearer. Especially I had this problem where if I take my player start again and I move it to another location right here, this button, once you activate it, it always stays activated. So I needed a visual cue to show the player that, okay, here the cable is not on, but once it is, if I leave the button, it remains lit. So you know that this has already been activated, and it makes things a lot clearer. It's also a much nicer look for the game compared to what we had before. If I go right down here, this cable is very long, so we can clearly see where this button is activating something. So in this case, I already activated it, so it's already lit. Let me quit to title menu and delete the save so that it's not activated anymore. So alright, you land here, and then here we've got a door which will definitely be updated later on. And then when I press it, got the animation, and now we can see that. In following updates, there will also be when you activate something, the camera will actually travel to where the door is, so that it's even clearer what's going on.
Just a quick note, you might have noticed that I'm injured. So I broke my clavicle 2 days ago, and it's gonna take about 6 weeks for me to recover. So the development of the game will be slowed down a little bit, but I will continue to work on it and work on making these videos. So bear with me for the next few weeks, and I hope to see you again very soon. Thanks a lot for watching. See you again soon. Cheers.